Now we are looking at the teaching video on quadratic inequalities. The topic is roots of quadratic equations. So when we consider quadratic equation with the roots alpha and beta, there are some important results that we have to bear in mind. That is, for the first one, the square of alpha plus beta. So if I expand that, I will get alpha squared plus 2 alpha times beta plus beta squared. If I want alpha squared plus beta squared as the subject, which is the idea of the next part, then I will have the sum of the two roots, alpha plus beta squared, minus 2 times of the product of the two roots. So that result must be committed to memory, but is derived from this simple expansion. For part B, where I have the difference of the two roots and then squared, the expansion will give me alpha squared minus 2 times alpha beta plus beta squared. So if I take alpha squared plus beta squared to be the subject of the equation, then I will have the square of the difference of the two roots plus 2 times the product of the two roots. This is another result that we have to bear in mind. For the next one, we may want to tie in with binomial expansion. You have the sum of the two roots, bracket cube. So what I have is 3c0 alpha cube beta to the power 0 plus 3c1 alpha to the power 2 beta to the power 1 plus 3c2. I have alpha to the power 1 beta to the power 2 plus 3c3 I will have alpha to the power 0, beta to the power 3. To simplify that, I will have alpha cubed plus 3 alpha squared times beta plus 3 times alpha beta squared plus beta cubed. So to make alpha cube plus beta cube the subject, I would have the cube of the alpha plus beta. Then take away 3 times alpha squared times beta minus 3 times alpha times beta squared. So this is the cube of the sum of two roots. If I just take out common factors here, negative 3 times alpha times beta, I'll be left with alpha plus beta. So you can see basically the second part of the expression would be 3 times the product of two roots times the sum of two roots. So that is actually obtained in the expansion using binomial theorem on alpha plus beta bracket cube. The next one, D, we are looking at the cube of the difference of two roots. So using binomial theorem, I will have 3c0 alpha cube times beta to the power of 0 minus 3c1 alpha to the power of 2 and beta to the power of 1. Now, I would have taken negative beta to the power of 1, but here you see only beta to the power of 1 because the negative is taken out there. So the positive and negative terms actually alternate. So the next one will be a positive. So I have 3c2 alpha to the power of 1 beta squared. Why this is possible simply is this. The second term is negative beta. If I square the negative beta, I will have beta squared. So that will be a positive. Next, I will have 3c3 alpha. Now that will be a negative term. Alpha to the power of 0, beta to the power of 3. You can see if I take the cube of the negative beta, I will have negative beta cube. Hence, this term is a negative term. So to simplify that, I will have alpha cube minus 3 alpha squared times beta plus 3 times alpha beta squared, then minus beta cube. Now, if I just take alpha cube minus beta cube as the subject, and I need to make adjustment here, that is a negative, then I would have alpha minus beta, the whole expression cube, minus or plus, this term when it's transposed to the left hand side becomes positive, 3 alpha squared beta. This term will become negative, so negative 3 alpha beta squared. Now this is the difference of two roots and its cube. I take out the common factors here. I will have, if I take out negative 3 alpha beta, then I will have, I'll just keep it as positive. I'll take out 3 alpha beta. I'm left with alpha minus beta. So, in short, the difference of the two roots cube plus 3 times the product of the two roots times the difference of the two roots. So take care, that is alpha cube minus beta cube. Now we look at the sum and products of the roots of a quadratic equation. So for a start, you can see here that the quadratic equation is 3x squared plus 2x minus 4 equals to 0. And it's specified that the two roots are alpha and beta. So a, which is the coefficient of x squared, is just 3. B, the coefficient of x, is just 2. And c is just a constant term. In this case, is -4. So we have this result which we'll use later on. A equals 3, B equals 2, and C equals -4. Now, using the value from the equation that we obtained, A equals to 3, B equals to 2, C equals to -4, we'll look at the sum of the roots. The sum of the roots basically is negative B on A. In this case, the B is just a 2 and A is 3. So -2/3. So that is the sum of two roots. Then the product of the two roots in the equation would be C over A, the constant term divided by the coefficient of x squared. C is a -4 and A is a 3. So we have -1 and 1/3. For part 3, we are looking at expression involving the sum and product of roots. So the first one, where we have alpha squared times beta squared, it can be treated as the product of two roots squared. So you can see if I just open the bracket, I would have alpha squared, beta squared. So the next one, we have got three fractions here involving alpha and beta. If I just combine that, making the denominators all the same, the first fraction I will have to multiply alpha beta to the numerator and to the denominator. I will have alpha times beta over alpha beta bracket alpha plus beta. The next fraction I will have to multiply beta times alpha plus beta to the numerator and denominator of the fraction. So I will have beta times alpha plus beta over alpha times beta times alpha plus beta. The third fraction, I will have to multiply alpha times alpha plus beta to the numerator and denominator of the fraction. So I will have alpha times alpha plus beta over alpha times beta times alpha plus beta. So that three fractions can now be grouped together. First of all, I have alpha times beta. And since I have these two factors the same, I will take that as the common factor, leaving me with alpha plus beta over alpha times beta times alpha plus beta. Now you can see this expression, though quite cumbersome, but involves only the product of two roots and the sum of two roots. So that's why we are looking at expression that we can simplify to just sum and products of roots. For part C, two fractions, and to combine them, I would have to make the denominators the same. So for this fraction, I will multiply beta squared to the numerator as well as to the denominator. I will have beta squared over alpha squared times beta squared. Plus, for the second fraction, I will multiply to the numerator and denominator alpha squared. So I have alpha squared over alpha squared times beta squared. To combine the two, I will have beta squared plus alpha squared over alpha squared times beta squared. But this can be simplified to, if I just put it up here, that alpha plus beta squared is simplified to the square of alpha plus beta, or just the sum of two roots squared minus 2 times the product of two roots, and then divided by the square of the product of two roots. So the three parts here, the expression eventually involve only the sum of two roots and the product of two roots. Let's look at D. And I can take out the common factors alpha and beta. Once I've done that, what's left is alpha squared plus beta squared. But that expression can be simplified to the product of the two roots, alpha, beta, times the square of the sum of two roots minus 2 times the product of the two roots. Next, part E, I will make use of the distributive law of multiplication. First, alpha times beta, then alpha times -2, so -2 alpha. Next, I have -2 times beta, so -2 beta. Then finally, -2 times -2 is +4. So I have the product of two roots, and here -2 times the sum of two roots plus 4. For part F, again I'll be using the distributive law of multiplication. I'll take 2 alpha times 2 beta. I have 4 alpha beta. Then 2 alpha times 1, I have 2 alpha. Then 1 times 2 beta, so I have 2 beta. And then 1 times 1 is just 1. The first one is 2 times alpha beta, 4 times alpha beta. The second one, if I take out the common factor, I'll have 2 times the sum of the two roots, then plus 1. As for the last one there, part G. Yeah? Instead of just opening it up, and that could be a very tedious way, I look for certain pattern. So if I can just take out the negative 1 from the second factor, I will have negative alpha minus beta minus 2 times alpha minus beta plus 2. You can see this is difference of two squares. What I mean by that is negative, I will have alpha minus beta squared minus 2 squared. I would have negative alpha minus beta squared plus 4. And this, when expanded, will give me negative alpha squared minus 2 alpha beta plus beta squared plus 4. So these two added up, I will have negative bracket alpha squared plus beta squared. Negative times negative 2 alpha beta, I have positive 2 alpha beta plus the 4. That is product of two roots. That's just a constant. I have to resolve this. That will become the sum of two roots minus 2 alpha beta plus 2 alpha beta plus 4. If I just multiply this negative 1 into this, I will have 2 alpha beta plus 2 alpha beta. So the final expression would be minus the sum of two roots squared plus 4 times the product of two roots plus 4. As you can see, this will greatly aid in our problem solving because we have been able to just reduce expression to just sum of two roots and product of two roots. This is the end of the video.